see my screen. I hope that you can see my screen now.
Yes, I can see your screen.
Okay, that is great. All right. So today we are gonna focus on sewer system design modeling basically, and what we are gonna focus on of like what we are gonna do is we're gonna focus on the sewer system basics. What will be happening at the steady flow simulation in gravity sewer. We're gonna see like how is pumping is happened. Then we're gonna see what is extended period simulation and how do we import the data using the model building and how do we do a constraint based sewer design. So that is basically what we are gonna do in our today demo. Well, what we are trying to do is actually during our designing of our system, what we are trying to do is to do a wastewater collection system to the what we call it the outflow or to your let's say station. So basically, the functionality that we are trying to do is first of all to pick up the right pipe size and the right invert elevation. And that came from expecting the load at your manhole. And when we expect the load, then we can know what will be the right pipe size and what will be our right invert elevation. After that, when we try to operate it, then probably we have extra load in the future, or we have like some bottleneck, well, an unexpected water coming. So we need to identify where is the bottleneck in the system. And after we identify where is the bottleneck in the system, or if there is any sewer overflow problem appears, so we need to solve them. And all of this is actually to meet the regulatory requirements. So this is like what we are trying to do in the collection system of the wastewater engineering. Well, actually, why to use sewer system modeling? Well, the first function is the subdivision design and master planning. So we need to design the network that will satisfy So we're going to use the steady state is being used for design work, typically for the extended extreme condition. And we're going to have like a snapshot of the system in the time. And then we're going to see how we're going to move slowly to the extended period simulation when we have a pump cycle, storage, and when we are in much more advanced, we might use the dynamic wave, and in this case, SewerGEMS is required. If you go to the SewerGEMS software, well, what we have is we need to give our giving data, which is like the system map and my layout, the physical properties of the network, like the pipe diameter, manhole size, the invert elevation level, and we give the system the loading data, how much of sewer we're gonna discharge in our manhole, also the rainfall data. And then the system will calculate for us the flow, the velocity, the depth in each conduit, the level in each node, and the runoff. So all this can be determined by the SewerGEMS software. Well, in SewerGEMS, we have multiple numerical solver. We're going to be dealing basically with a gradually varied flow convex in SewerCAD for designing our network. And then we can analyze the extended period simulation of this either with SewerCAD or with SewerGEMS. Also, SewerGEMS can do storm, but we are not gonna go deep in storm in this time, except rather than just the inflow and infiltration, and how do we calculate inflow and infiltration in the SewerGEMS or SewerCAD. So these are the numerical solver. We get multiple solver. As I told you, we're going to depend basically in the convex gradually varied flow. And we're going to use it to design our network. And we're going to see how our network will looks like after we design it with SewerCAD. We get as well gradual varied flow rational for the storm, but we are not going to go through with this demo because it's related to the storm. We're going to focus mostly on the SewerGEMS. So for the SewerGEMS, we get like the elements that we are going to use in our network. It's actually, first of all, the links like a pressure pipe, conduit, getter, and channel. We have the low impact development control. We have the wet well, pump, probably SCADA element. Also, we have the nodes like the manholes and the outfalls, which is like going to be basically used by the sewer GEMS and SewerCAD. In the storm, we might be in the catch basin, and well, like in the pressurized network, we might use the junction chamber and pressure junction. Also, in the storm, we might get catchment, pond outlet, and head well, but we will not be using during the sewer. SewerGEMS is actually a software that's run on top of a multiple platform. In our class today, we're going to use the standalone one, but it's also run on top of AutoCAD, on top of ArcGIS, and on top of MicroStation. Hopefully soon we're going to get it on top of QGIS, but it's still under development and it requires like a bit of more time. Well, when we design sewer or storm, then we might connect it to other Bentley products like OpenRoad, InRoad. And we can also import data from the AutoCAD Civil 3D. So if you have a land XML data, we can import it directly into SewerGEMS. We're going to talk about the modeling process during the demo. So at the end, what we have is the data entry. We're going to see how we can do it. And then we can use, we're going to use like some models, and we're gonna go to see how it works. But at the end, if your data entry is not good, you're not gonna get a good result. So what we have to say that always garbage in is gonna result for you a garbage result. So the garbage will be out. All right. So basically, when you design, I have seen multiple people designing on an Excel sheet. So, like what we have here, when we have an effective design, this is Abu Dhabi. You will find a lot of people design on an Excel sheet, and we don't prefer this. So that's what we call it a disconnected design. So when you need to modify your data, you're going to find yourself that you are not designing in the proper way. So we give the SewerGEMS, we give you the modeling. So when you design over the map, you can decide, and then we can get your profile. And then when you move your manhole, it's going to be connected. And that's what we call it, connected design. So in the connected design, you design directly. When you do modification, it will be replicated, and then your value will be different. But when you give it a single run, you're going to be in the connected design again. Let's have a look at the software. So let me just open like multiple file. Uh, and let me start with such a file. All right, so, well, this is just like a schematic drawing. And in this schematic drawing, what we get here is few manholes, like this one. And I get like pipes. When we do such a schematic diagram, what we need is like few data. So first of all, what we need here is my manhole, and my manhole is actually required some data. Basically, the data that I need is my elevation ground and my elevation invert. And what is the structural type of the manhole? What is the diameter? So this is basically the data that I require. Once I fill this data into here, what we call it the physical properties of the manhole, then what we need is the load data. And my load data will be in my loading data here, and I need dry sanitary dry weather load. And I can see it in the sanitary load control center. So here I can basically see what is my sanitary unit load and what is my loading unit. And I can see here, for example, it's an office with a loading unit of a 200 employee, let's say, or I got like a hotel per customer with 500. Now, my counting loads, they multiply my units loading here with the sanitary units loads here. And here I can see multiple options. If I want to add to these options here, actually I can add it, and that is what we call it as unitary dry weather load. So here I have added the office customer per hotel, and I can make new, and I can make like account-based one. And I can say, for example, that is Nairobi standard, let's say home or wherever. And I can give it here how many liter per day. For example, let's say they're consuming 300 liter per day, and the capita, for example, is 2. When I'm done, if I go to the again to the sanitary load control center, I can see here my I can see it here down in the option. Also, I get here an engineering library. And I can add any from the engineering library. For example, school per student, etc. The unit loads is a student, so I can add it as a school per student, as a hospital, as a theater. So I get here a lot of in my engineering library, and I can customize this engineering library to my needs. Now, when I go to the my flexible table, and if I go to my manhole, and I can see like so far I don't have any hydraulic grade line, any energy grade line, because I did not run it yet. All what you can see here in the yellow, it's either a result or something that I could not edit here. If I compute, I got here multiple scenarios. So this is the average day. When I compute, now if I get to my flexible table, and I have a look at my manhole, I can now have a look at, sorry, let me just use my unit formatting, do precision 2 to see what's happened beyond the dot. I can see what is my flow, what is my depth, and how is my hydraulic grade line will looks like. When I want to go to more information, I can go and I can build a profile. I don't care about this profile. I'll build a new one, and I will label it as August 25th, E1. And when I select from the drawing, for example, I want to see how my profile looks out from manhole 6 to the out. And if I go and I open my profile, I'm going to see here how my networks looks like. And if I go to add an annotation table, I'm going to see here like, okay, this pipe, for example, is a 200 millimeter. and the flow is 1.1 liter per second, and that is my slop. Yeah. So I'm going to get all the information of the manhole, all the information of the pipe, and I can also go to my profile here, and I can see it as an engineering profile like that. And I can see this one, I can export it to AutoCAD as well. And I can export it to a DXF file, but also I can change my profile annotation and what I want to see more on my conduit. For example, if I want to see, well, like, let me see, for example, I can add my velocity. And I can say it's V equal, and I want it a little bit down. And it doesn't go down. I think. Let me just like make it more. Yeah. Okay. So here you can see I have added. Sorry. The velocity to the annotation. So either I can add it, or I can remove it. In order to have my profile look perfectly, or how I would like it to looks like. Yeah. So I can do this with my engineering profile before I export it to a DXF file. All right. So now when I want, for example, to extreme my flow, and go to the very extreme flow, I can go to the component, and I get here the extreme flow. So here I have like a peaking factor, but some people might use different methods. And here, most of you use Babbitt equation. Please correct me if I'm wrong. Some use Fedro, some use Harmon. Well, instead they're using peaking factor US. So it depends, or 10-state equation, etc. So here we have the formula of the engineering library that makes your flow extreme. When you're done from that, you can go to the extreme, what do you call it, extreme flow setup. And then you can go to the peak flow here and then choose the extreme flow setup. And if you have like any multiplier over there, after that, you can go to the calculation option. And here I get like my peak flow run in the extreme flow setup there in the loading. I choose my peak flow setup. If I choose this one, you can see here that is my network. And let me just like put this, increase this to the flow. I don't like it like this. So I can go there and I can say, well, that is Q equal, and I need my my flow to look like that. And well, let me now increase the flow. So I just can choose with my scenario to the peak flow. I can make it current. When I make it current, it will appear in the box here. And then now I'm running this scenario. And you can see here, you can compare as well between the two scenarios from the box here. So this is like the average day. And then when I extreme it, it will look something like this regarding the flow. Yeah, and I can color code it using the either velocity or the flow, etc. But this is like an easy happening over there. So basically, this is like the steady state of the uh, sewer gems. Now the question is, what's going to happen if I get too deep down? Yeah, too deep down, and now from there I get my outflow. But actually, this was wet well, and then I want to go out from the wet well up again. In that case, we need to add more elements. So here I got like normal gravity. You can see that this is a very normal gravity one, and I can easily create any profile. And I can see how my profile looks like that. For example, if I want the profile to start from here to the outflow, and I need to open the profile like that, and I can see how it looks like, and I can check it in the profile table. And I can see how my profile looks like, what will be my flow, what is the slope, etc. So now we need to go a little bit more further, and then we need to add pumps to that. Let me add one with a pump. So in order to change between gravity system and to pressurized one, this outflow should be not a wet well. It should be sorry, it's not an outflow. It should be changed to a wet well. Just a second. It will open. All right. So in my case here, I get always is a gravity system until my wet well here. And then from the wet well, I get two pumps. One is a standby, and one will be working. And then I will pump until a manhole here, and then this manhole will be connected to the outlet. When I add a pump, I need to tell my system how is my pump is operating, and what is my pump size. And that's what we call it pump definition. So if I double click on the pump over here, and if I go down, I get here in the physical something called pump definition. And if I want to see my pump definition, this is my pump head curve. So this is the head curve. This is the efficiency curve in red. Yeah. And I know that my pump is pumping at 66 liters per second for a head of 9.14. That's how it is designed. And that is my efficiency curve. It's like 70% at the best efficiency at 50.5. So this is my pump specification. If I run this model, and if I go to see like how my flow looks like now and how my profile looks like, I can create new profile. So for example, if I want it from the last manhole here to the wet well, and it will goes all the way down. To the outfall over there. Ah, wait a minute. And if I open my profile, it will look something like this. So here, the last manhole, and that is my wet well, and I can see that I got a pump over here that is pumping, which means it's giving me an energy that rise my hydraulic grade line, and then I go back again to the gravity over there. So in that case, I get like, when I see something like this, I should know that there is a pumping station over here. Okay. Now, what is the effect of the pumping station over my network and over my load? And you know that my load is changing over the time. Since my load is changing over the time, I need to reflect these changes to my network. In order to reflect the changes to my network over the time, we have to build something called patterns. And the patterns is the multiplier of the average load, which is registered in the load control center by the time. And in that case, we can get how my load is changing over the time. Let me open for you an extended period simulation case and show you how this happens. All right, so this is a network that is operating under gravity. And let me show you how it operates under the extended period simulation dry weather load. Let me compute my network. And now, before I move to extended period simulation, let me show you like the steady state with dry. Normally, what we get here, that is my network. I have a divergence here as well. I can see the divergence because it says it's a diverted pipe. When you get this symbol, the half circle on the pipe means that there is a divergence. And now, if I want to check how it looks like, the best way is to get it through profile. So, well, let me show you this from this manhole 12, all the way to the output. I can see here that I'm going by gravity, and it goes too deep. And then I added my pump to my wet well, and I add the energy. It goes to the manhole. Let me add the annotation table. It goes first of all from manhole 12 by, and then I get my wet well, and then my pumps, and then I pump all the way by a force main to manhole 3. And that is the description is here. I go from manhole 12 to the wet well, and then my pump is pumping to the manhole 3, and I go all the way down. That's under steady state condition. But now I know that my sanitary load is changing over the time. Why? Because our behavior is changing over the time. So let's have a look how we can change the behavior over the time. In order to change the behavior over the time, we need to calculate the average, and then we need to calculate the daily usages, and then we over the time, and then we divide this by the average, we get a multiplier, we call it pattern. Patterns is a type of a component, and then my patterns is over here. It's a diurnal patterns over here, the extended period simulation patterns, and I can see that my average is over there, and I pump below my average for a few hours, then above my average for a few hours, and then I get too low. And then what's gonna happen if I make this applicable to my loads? In order, first of all, to assign it to my loads, I have to go to the load control center, in the component, and I need to say, well, this load have a pattern. That is a fixed load, but now it gets my pattern, yeah? And when it gets my patterns, if I run it, the changes will be reflected with a pattern. So if I graph the flow, it will reflect the patterns as well. So if I right click here and I graph the flow here will reflect the same patterns over here. Yeah, you can see. So it should reflect the patterns that is assigned to that load. So now, since the patterns is reflected, of course, this is a multiplier, and that is the result. That is gonna change my load over the time. In that, I go and I open the profile. My profile will look like something like this. However, yeah, you can see here my flow, but that's at the time 0. My flow is 5.86, and then it will increase after that here. Yeah. Okay. If I click the play here, and then my time starts to change, then you can see my flow is changing accordingly. And my wet well level is changing. And then my pump will be off until my wet well level reach to a certain amount. Then my pump is on, so my level in the wet well will be decreased as well, and then it will go forth and back. All right. So what is the effect of this on my pump cycle? I can go there and I can click on the pump and I can graph and I can see how my pump cycle looks like. So here I can see that during 24 hours, it have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times it shut down and start. Okay. Can I reduce this cycle? Well, the answer is yes. Yeah. And how we can do this? By increasing the wet well size. So if I double click here on the wet well, for example, the wet well having a diameter now of 6 meters, I'm gonna say, okay, what's gonna happen if I increase from 6.1 meter diameter wet well to 18.3? Yeah. And if I compute, and if I graph my pumping, and I can see that it will be more time off, and then it will pump again, it will empty the wet well, and then it will go down. Yeah. So this is the effect of the, or how we want to do a balance between the wet well size and the space that I have and the pump, let's say, capacity. And that's how it's done. So if I return it back again, let me, for example, change this one to 12.2. And if I compute again, you can see the effect of this on the cycle. Yeah. So I can balance it, and I can between the wet well and the pump and the pump cycle, and how I want my pump cycle to look like. Anyway, well, also during that is during the dry weather. Yeah, I'm gonna ask like, okay, what's gonna happen if I have a wet weather? Wet weather means extra load, and it comes through two types. First of all, infiltration on the pipe due to crack, etc. So the pipe, depending on the water table, might get into the pipe, and so the water level will be higher. Or what we call it an inflow, that is happening over the manhole. Yeah, so it's like a water coming through the manhole crown, and it gets in and it goes with the water. So this one required some measurement in the field during the wet weather. However, we can add it to our data, and then in there, first of all, like the infiltration, it's a property of the pipes. So if I go here to the conduit, and in the conduit here, I get something called infiltration and inflow. If I change this one from dry weather to wet weather, I already registered it here. So I can add the infiltration over here by getting this as infiltration per rise length. And then I can get here like, well, a net. So I can say millimeter per kilometer. And here it's like a liter per day. And I can measure it, and I can give it. Global date, liter per day, 1,800, for example, whatever. And well, and if I close, and if I give an inflow actually, the inflow normally comes at the manhole, and it looks like the bell curve, and that is a kind of an alternative here. We call it wet weather, and sorry, that is conduit, and that is the sorry. In the manhole, I can see here I got like 4 of them, and that's how it looks like. And I can graph it, and that is a field measurement actually, which is like a water that is coming into my system. Anyway, I have seen that I got like my manhole here and my conduit. Conduit. Okay, so this is my conduit. I get my wheel over there, and then I can compute. And now I can see how my network will operate. So I can go to my profile, and I can see that I have here, if I operate in this way, I'm going to get like few overflow over there, And that means that the diameter need to be increased. It was okay over here, but there is multiple places that get flooded. All right. Now let's move to the design stage. And how do we do this in the design stage? Let me get like a design example. Mm. If I want to do design, first of all, I have to start from a background layer. So normally, what we do is, well, I'll tell you what. Let me try this one to do a design for. Yeah, let's see what James by mistake. It's a storm case, but anyway. All right. So what I get here is a network that I need to design. The first thing that I need to do is to build my network layout. And let me just start with a base. Yeah. And I just put my network layout here. When I design, first of all, I need to do my calculation option. So my calculation option, that is my normal one for the analysis. But I have to create another one for the design. In the design, I need to be in steady state, gradually varied flow convex, like the SewerCAD calculation engine. And then I can change this calculation type from analysis to design. If I choose any other solver, I can't find the design here. So I have to gradually varied flow convex. And then this one should not be EPS. It should be steady state. And then here I can change this from analysis to design. But if I click here, and for example, that is if I change this to extended period simulation, I can't choose anymore the design when it's only analysis. So steady state have the calculation type of design. Then when I draw my network should be from a catalog. So here, for example, I can see that I got my conduit type is a conduit catalog. It's a circular PVC, and then it have multiple diameters. Let me change all this one from 300 to 200. And I will get my all invert elevation similar to the output. So if I look at my output here, it have an invert elevation. Let me see my physical of 149.35. And then I will go to my manhole to put all of them similar. And now I think I'm on the scenario of base. And if I go to the calculation option here, it's the base calculation option, which is the analysis. Let's change this one. And if I click on there, let's have a look. It's a gradually varied flow analysis. And I want to see what's going to happen. Yeah, I got my load and I updated my load. And of course, my network will not look good. So if I go to my network over here and I choose to create a profile, and that is a new profile. Let me take my profile from here all over here. And that's how my network looks like. It's flat, it is bad, and I have no slope. And I don't know, like now I need to design this. In order to design, I have to give my network my design criteria, a condition-based design. And you can see here, all my network is 200 millimeter. It's a flat network. It goes all the way to the outfall flat. And I need to change this. So in that case, I'm going to go here to a new scenario. I'm going to create a new child scenario out of this one. And sorry, no, not from this one. I need it from the base. And now I'm going to call this one Nairobi 2025. 25 August 2026. Now, in this one, I'm going to say, well, my calculation option now is not an analysis. I want to go to design automated. And in the design automated here, I need to go to the calculation option to make my constraint-based design. Yeah, so this is my automated design. In the alternative as well, I can go to my design, and I need to put, this is Nairobi code. In Nairobi code, if I come here, I'm going to say, well, design for me, the velocity constraints type is very simple. I need minimum velocity of 0.61, maximum velocity of 4.57. I can go to the cover, and I can assign a minimum cover of 91 centimeter. And I can go to the slope, and I can put, for example, the slope between, let's say, 0.3 and, for example, 11%. And if I have any attractive stress shear, I can add it here, forces. And then I can go to the percentage of pull. And I can say, well, maximum 7. Yeah. Now I'm done. I can go to the scenario here. I say, please design for me according to Nairobi code. Design for Nairobi code. And I need to change the calculation option from analysis to design. And now when I run this one, it will create for me a new physical alternative. Now I can have a look at what happened. It designed for me the network from scratch. And if I go to my profile, it will look something like this. Yeah. And it will assign for me a new invert elevation, a new slope, and a certain percentage of full. And that's how the design works into SewerGEMS software. If there is any question, I'm done from the presentation of today. If there is any question, please let me know. We will have our agenda for 4 days, and the agenda, that is the agenda of training we are proposing. So we're going to go through the hydraulics and hydrology principles. We're going to do like a few workshops, discuss extended period simulation, discuss unsteady flow and extended period simulation. Then geospatial data tools and how to design a gravity sewer system. And the 4th day, we're going to get some of your data. If you don't, we have our own data as well. And we are going to make a design project from scratch and see how we can select the pipe size, select the right wet well size, select the right force main, and select the pumping station according to the electricity. If you have any question, please raise it. I can answer it. And thank you for listening.
Thank you so much, Engineer Muhannad. As you heard, if you have any question, please drop it in the chat box. That was an insightful demonstration. What we have seen here is a practical example of what we spoke about at the start, that we cannot manage what we cannot measure, what we cannot understand, and what we cannot model. And here we've seen how we can model different scenarios to a point where we are able to make data-informed decisions. So Engineer Muhannad has also shown us how exactly this principle comes to life through WaterGEMS. So if this session has done anything, it should have shown us, should have shown you that digital modeling is no longer optional. Yeah, it is becoming core skill for everyone working in water and wastewater infrastructure. So that brings us to the next segment. Many of you may be asking, how do we build this capacity for our team or for myself? That is exactly what we will address in our next segment. So let me do a presentation. And as I make this presentation, I would like to, just a minute. Yes, I'd like to invite our Business Development Officer, Mr. Evans Ngetich. Over to you, Evans.
Yeah, thank you, Mercy, and I hope you can hear me. Thank you also to Engineer Muhannad for the very insightful demonstration. So like Mercy has said, if you are asking yourself, how can you participate or how can you get to learn more about the WaterGEMS and SewerGEMS software? Good news, we have 2 sessions upcoming in September. From the 14th to the 18th of September, we'll be having WaterGEMS training happening in Nairobi. From the 21st to 23rd, we'll also be having SewerGEMS training also happening in Nairobi at the Golden Tulips Hotel. So if you would like to participate or if you are eager to learn about these 2 softwares, you can reach out to us. You can visit our website, you can write us an email or call us, and then we'll make sure to get you registered. So you may also be asking yourself, what is in it for you? What do you get if you participate in this training? So first, you will get a Bentley system certificate. This will make you to be among a handful of people in the continent actually who have such certifications. You'll also get to network and share ideas with professionals in the water and sanitation industry. And apart from that, and even a lot more importantly, getting trainings on these softwares will allow you to solve problems that you may face within your profession or in your country where you are. So please reach out to us, contact us, fill the forms and register, and we'll book your seat on the 14th to the 23rd. Spaces are limited, so I would urge that you send in your inquiries quickly and make your registration as soon as possible, now that we have almost 2 weeks to the 2 sessions. So I'll be happy to answer any questions regarding the trainings. So please post them on the chat if you're watching on LinkedIn. If you are here on Zoom, please post your questions and I'll be happy to answer them. In the meantime, Mercy, you can take back.
Thank you so much, Mr. Evans.
Regarding Michelle Najam, for the pricing of the software, well, actually, unfortunately, I'm not a sales guy. Sorry. But you will be contacting IRES for this. They will contact our regional sales director, she's Mr. Ruth. IRES have a good relationship with her, and then they can send you the quotation. So most probably Grace or Mercy can handle this request for you. We can have a separate online meeting, and then we can discuss your needs first. And then according to the needs that you have, we can discuss the price. We have multiple tiers of the pricing of Bentley. It's either perpetual license or a subscription license. Well, if you are an operator owner, we normally and you use it in a daily basis, we ask you to go for perpetual. If it's a project base, then we advise you to go to subscription based license. We will have let's say a separate meeting with IRES and you to discuss your needs, number of pipes, because even the licenses have different product tiers. And a number of pipes is an important factor for us. So we need to look how big is the project that you are expecting, and according to that, we can understand the price of the software. Thank you, Michelle.
Thank you so much, Muhannad. And Michelle, I hope your question has been answered well. As we come to close, we return to where we began. We say that we cannot manage what we do not measure, understand, or model. And today, Engineer Muhannad has shown us how, the tools and the techniques that make that possible. And also we've had Mr. Evans, who has shown us the next step, how to build the capability.
Hello? I think I missed the voice.
Can you hear me now?
Yes.
Yes, I'm saying resilient sewer networks are no longer an engineering outcome. They are a public health outcome. They are an environmental outcome and a contribution to SDG 6. So every one of you on this call, engineers, utility managers, consultants, planners, project managers, decision makers, has a role to play in this outcome. So on behalf of IRES and our partners at Modeling Experts, I want to say a big thank you to Engineer Muhannad for sharing your expertise so generously, and Mr. Evans for outlining the path forward. So thank you to every one of you, our participants, for creating time to join us once again from the start to conclusion. We are grateful. If you have any questions that we did not get to, and if you'd like to get more information on SewerGEMS certification program or any courses shared today, we also have WaterGEMS within the same period. Please reach out to us, and our contacts will be shared. Also follow us on our social media platforms, on LinkedIn, on TikTok, on Facebook, on Instagram, and let's keep in touch. So this brings us to the end of our session. Thank you once again. Stay safe. We look forward to connecting with you in our next engagement. A big thank you also to my team working in the background, Mr. Eric, Hilary, and the other team in the office. Thank you so much. Have a fantastic remaining part of your day. Thank you and goodbye.
Thank you. Goodbye.
Bye-bye. Still